Okay, so we are continuing covering section 6.3, and this time we're going to talk about scientific notation. So this section kind of takes a bunch of stuff that we've talked about previously in chapter 5 and shows us a bunch of applications. So we've done ratios and rates, and we've seen how that gives us a way of solving with proportions. We've done percentages, which we have problems that deal with that. Now we're going to move into scientific notation, which is obviously applied in science. So scientific notation was introduced in order for us to handle really large numbers and really small numbers without needing to write them out. So it's a way of writing really large or really small numbers. Okay, so the form for scientific notation looks like this: A times 10 to the B. And A is always a number bigger than or equal to 1, but smaller than 10. So it's a single digit number. And then B is an integer. And if I were with you, I would say, what's an integer? And oops, the answer is an integer is a positive or negative whole number. Okay, so let's just kind of refresh our memory of how scientific notation works. So let's see, 2 times 10 to the negative 4. That's an example of scientific notation. Or 3.8 times 10 to the 7 is another example of scientific notation. Let's convert into standard notation. So the scientific notation, we have to kind of be mindful of where the decimal is. So like in this first problem, I don't see the decimal, but in the second one I do. 3.8, I definitely see the decimal. But in this first one, the decimal would be right after the 2. And the negative is indicating a small number. So a negative tells us, oops, we're looking at a small number. I'll use the hashtag symbol, but that's really the number symbol. Whereas a positive is a large number. Now we'll talk about why that works in just a second, but let's convert it into standard notation. So as a number then, when you see 2 times 10 to the negative 4, that negative 4 indicates to me that I need to move the decimal 4 places to the left. So if I were to do that, that would be 1, 2, 3, 4, which means I need to add 1, 2, here, I'm going to erase that. 1, 2, 3 zeros right there. So in standard notation, this would be 0.002. Okay. The second number here, 3.8, is being positive, means I'm going to move the decimal to the right. So I would go 1, 2, 3, 4, 5, 6, 7. Now, I'm not going to erase what's there, but I do need to add then, oops, no decimal anymore. 6, 1, 2, 3, 4, 5, 6 zeros after that. So 38 million. That's the standard notation. Okay, now before we practice some more with this and why we bother with scientific notation, I want us to understand why this completely makes sense. So really quick, 3.8 times 10 to the 7. So 10 to the 7 means 10 times itself 7 times. So if you times 10 7 times, I do the right number? 1, 2, 3, 4, 5, 6, 7. Okay. And you're timesing it by 3.8. The first that you might remember moves our decimal literally one place. So I have 38. Then every 10 after basically just adds a 0. So 0 for the first 10, 0 for the second, 4 more zeros. So that's how multiplying by 10 works. And that's why this is giving us a large number, because we're multiplying by tens over and over again, and we're just adding zeros or moving decimals. Okay, so if that is how 3.8 times 10 to the 7 works, then when you have a negative, now, I don't think we've talked about this, but you might recall from algebra many years ago in your life that a negative exponent, if you have x to the negative a, that really can be thought of as 1 over x to the a. So in other words, 1 over 10 to, I'm sorry, 10 to the negative 4 can be thought of as 1 over 10 to the 4, which means, in essence, I'm dividing by 10 4 times. Now, 10 to the 4, if I write that out, that's 10 times 10 times 10 times 10. Sorry, I'm gonna center the 1. Okay, which is actually 10,000 when I actually write it out. So 2 times 1 over 10,000, which as a fraction is 2 over 10,000, right? Because I multiply fractions. I can put the 2 over 1 and multiply straight across. We did that previously. But as a decimal, which is the 4th one, oops, which is what I said. Back up here. 2 in the 10,000s place. So this notation is basically saying that we're either multiplying by, place it in a place value behind the decimal, a certain distance back, depending on what place value we get to. So in this one, it was the 10,000s place. It could be the millions place or whatever. That's how scientific notation works. Let's do another one though, where we convert. Let's actually start with the standard notation. So let's say I want to write 3,800,000,000. Here, let me pick different numbers than 3 and 8. Let's do 5,800,000,000. There we go. Okay, so okay, there we go. 5,800,000,000. So I want to write this in scientific notation. So basically, I need to figure out how many tens I have to multiply by, or find the decimal, and I need to figure out how many times I have to move that decimal. So I'd like the decimal to be right here between the 5 and the 8. So I need to move the decimal 1, 2, 3, 4, 5, 6, 7, 8, 9 times. So in scientific notation, this would be 5.8 times 10 to the 9, because that would move the decimal 9 times and I would get 5,800,000,000. Okay, so let's try a small number. Let's do point and do 6 zeros, 4. Okay. So to put this into scientific notation, I'm going to need to move the decimal between the 7 and the 1. The reason it needs to be between the 7 and the 1 is my final answer, 7.14. That's going to be in scientific notation because that number is between 1 and 10, right? Remember, we said it always is between 1 and 10. So 7.14 is between 1 and 10. Okay, so how many places do I have to move it then, this decimal? 1, 2, 3, 4, 5, 6, 7 places. And because this decimal is representing a small number, I need to have this as a -7. So it's representing a tiny number, which means we're moving it to, I think, the millionth place, 10 millionth. I can't remember. Okay, but that's how we use scientific notation. Now, this is really where it's useful. Yes, writing these giant numbers in smaller notation is easier, right? Writing it like this is easier than writing it like this and figuring out how many zeros I have to have. But it's really useful when we use it in actual calculations. So like, for instance, if I want to multiply two distances and they're big, it might make more sense to do it in scientific notation. So let's say I want to multiply 6.3 times 10 to the 8th. And then I want to multiply that distance times, let's do 5.21 times 10 to the 4th. So two decently large distances, the first one especially. And if I want to multiply them in scientific notation, what's really nifty is I basically just have to multiply like the corresponding pieces. In other words, I'm going to multiply the decimals, and then I'm going to deal with 3 times 5.21. So that's 32.823. That's multiplying the two numbers. Now I'm going to multiply the tens. So I have 8 tens and then an additional 4 tens for a total of 12 tens. Basically, what I did was add the exponents here. That's kind of using a little bit of an algebra trick. Now, there is a problem. This answer right here is not scientific notation because the number is not between 1 and 10. It's bigger than 10. 32 is bigger than 10. So I need to move the decimal one more place. I need to move the decimal one more. So I need it to be 3.2823. So that means I add an extra 10 to these tens. So I add a 1 to the exponent. So when I moved that decimal one more place, I ended up having to compensate by putting it in multiply by. All right. But now I didn't have to write out these terribly large numbers and then grab my calculator and do it there, which, by the way, the calculator would have given you scientific notation because it can't fit this number on the screen. FYI. Okay, so let's just try another one. Let's do one where we have like a negative exponent, kind of a weird one, right? So let's say we have 1.55. I'm going to write the number. There we go. Times 10 to the, let's do 7. And then I'm going to multiply that by 3 to the -4. Okay, so multiplying those. So first thing I'm going to do, I'm going to multiply the decimals. 1.55 times 3.6 times 3.6. Okay, that gives me 5.58. Well, that's nifty because that's going to be scientific notation. I don't have to change my answer. Nice. Okay, but when I multiply the exponents, I have 10 sevens, but here I have -4 tens. Sorry, I said 10 sevens. I meant 7 tens. But here I have 10 to the -4, which means I'm dividing by 10 4 times. So I just said earlier, you add the exponents. Well, we're going to add those exponents. We're going to add them. So 7 plus -4, that's +3. And it works. That's the answer. So we add those exponents together and life is good. And that's really it. So that's kind of the applications we'll look at for scientific notation.